Let's talk now about alkyne ozonolysis. So that is the reaction with ozone. So let's write this. My alkyne. I'm going to draw a terminal alkyne. So 1 propyne. And if we treat it with ozone and say water, we're going to produce, this is going to break. Now what we're going to need to remember to predict products, and this is going to split like that. Oh, let me just not do yet the terminal alkyne. I'm going to do that. When we do that, so methyl ethyl acetylene, or ethyl methyl acetylene, alphabetic order. So that will split the alkyne into 2 molecules, and in this case they're different because here I have an ethyl and here I have a methyl. So what that produces is 2 carboxylic acid. The first one, so to draw that carbon is going to be now a carboxylic acid, and you're going to have another product, the carboxylic acid at this carbon. So you have 2. It's going to have it at the end like that. So 1, 2 carbons, and here you have 1, 2, and 3. 1, 2, and 3. That. So when it is an internal alkyne, we have carboxylic acid, and you will have 1 product if this is symmetrical, of course. If you had a metal, then you will have 2 moles, so we can write it down. If this was 2 butane, and you did exactly the same, ozone and then water, this case you're going to have, because you split here, you're going to have 2 moles of the same product. So having 2 carbons, so what you get is acetic acid. You're going to get 2 moles of acetic acid. Now what happens if the carboxylic acid is terminal? Well, if the carboxylic acid is terminal, let's see, let's draw it here. 1, 2, and 3. I'm not drawing the hydrogen, it is there, right? That's when we call the alkyne terminal. So you will have an H there. And again, in that reaction, you're going to be splitting that and producing. Now, in the case of the terminals, you get a carboxylic acid and you form carbon dioxide. So one of your products is going to be acetic acid. Notice 1, 2 carbons, and the other is carbon dioxide. So only 1 carbon there. So that's what we need to remember. If it is symmetrical, 2 moles of the same, and being internal. And if it is terminal, 1 mole of the acid, 1 mole of carbon dioxide. If it is not symmetrical, you're going to get 2 products. And let's just contrast that with what we know of alkenes. So in the case of alkene, I'm going to make a separation here. When we did alkyne ozonolysis, we do this, and we treat it with ozone. Again, you're going to split that, but in this case, you're going to produce either aldehydes or ketone. Because this is unsymmetrical, you're going to get acetone, so 1 ketone and an aldehyde. The other product, I'm going to draw it on top, then here, there's 1. And if, of course, this was symmetrical, then you have 2 moles of the same ketone in this case. So depending on what is the nature of your substrate, here you will have 2 moles of acetone, for example. So we just need to remember that ozonolysis of alkynes produces, in general, carboxylic acid. And of alkenes, you get aldehydes and ketones. So depending on the symmetry about the triple bond, you will get 2 moles of the acid or 2 different acids, or if it's terminal, acid plus carbon dioxide. So as opposed to what we get when you treat alkenes with ozone, in which you get, here you have a ketone and aldehyde, that's a non-symmetrical alkene, or 2 moles of the same. Of course, you can get aldehydes, say that you want to, if you have that, and that's trans-butane, when you do the ozonolysis of that, you're going to get 2 moles of acetaldehyde. Remember that we have 1 hydrogen there.